So as we mentioned earlier, the media is not going to make or break you. It's not like they're just going to say, hey, what grows on McConkey? But they're going to put it in a vignette format. So that's where it's really important to understand the different types of media. And again, we'll hit that again when we talk about each organism specifically. Similarly, the oxygen requirements, again, they're not just going to say which of the following organisms is a strict aerobe, okay? But it can help you. And I'll give you some examples. Strict aerobes, for example, if we look at this next slide, we can see obligate aerobes. They list Mycobacterium and Pseudomonas. So those are the two examples I'm going to give you. Obligate aerobes cannot ferment. They require oxygen at all times. TB is a good example because tuberculosis, being an obligate aerobe, prefers the apex of the lungs. I actually had a student in a live lecture once ask me, she said, the TB patients in my village, they used to bring them up to the tallest mountain in the village, and this seemed to make their TB better. Why is that? I said, well, because the higher you get up in altitude, the less oxygen there is. And with TB being a strict aerobe, less oxygen, it would have trouble growing. So that actually, not probably the simplest of all treatments, but it actually would work. Pseudomonas is another really good example of an obligate aerobe. And the reason is because a lot of the infections caused by Pseudomonas are very similar to those caused by the Anaerobacteriaceae. So the cellulitis, urinary tract infections, for example. And one of the first reports that you would get back from a lab, AKA, would be found in the vignette. They might say, you have a patient comes in, they're presenting with frequency, urgency, dysuria, maybe hematuria, and they isolated gram-negative rods that are non-fermenters, okay? Now, that is a huge clue, the non-fermenter. When you see that, you'll know that that UTI is due to Pseudomonas, because all of the enterics, all of them, can at least ferment glucose, okay? Now, they're differentiated based on whether or not they ferment lactose, but they're all facultative anaerobes, which means they all can at least ferment glucose, okay? So those are two examples where that might come in handy. The microaerophils, I'm going to say, is probably less important that you know. Basically, Helicobacter and Campylobacter are microaerophils, so they like oxygen, but they like a little bit of CO2 in there as well. And they may mention that somewhere in their vignette. We try to culture, or we cultured it with oxygen and a little CO2. But other than that, I probably wouldn't worry so much about the microaerophilic organisms. Almost, really the bulk of the bacteria are facultative anaerobes. So they're okay when you have oxygen, and then when you don't, they're just like, don't need it, I can ferment. So all the enteric organisms are facultative anaerobes. And if you think about this, think about what happens in the formation of an abscess. In an abscess, you generally are going to have some anaerobes, right? You have some anaerobes in there. But who likes to get in there? Most anaerobic infections are polymicrobial. And who gets in there with the anaerobes? Somebody that doesn't necessarily need the oxygen. So the enteric organisms in an abscess are often part of that polymicrobial mix that you'll see in an abscess or an anaerobic infection. And then last on the list here are the obligate anaerobes. And by far, there are fewer of these than a lot of the other groups. As far as the ones that are clinically relevant, I know at this point you feel like you've got so much in your head you can't even think. But if you can remember your ABCs, which might be a stretch at this point, you can remember the obligate anaerobes because they follow your ABCs. So your A is actinomyces, your B is Bacteroides, and the C is Clostridium. Now, yes, you have other anaerobic species in the mouth, but you're not expected to know specifically all of those different species. But actinomyces, Bacteroides, and Clostridium are strict anaerobes. Now, how is that going to help you? Well, you're reading a case, and depending on which organism they're looking at, they'll say the organism did not grow in the presence of oxygen. isolated the organism from the patient, wouldn't grow in the presence of oxygen. What does that mean? That means it's one of the ABCs. It's an obligate anaerobe. Okay, so just like the media, again, they're not just going to ask you which of the following does this, but it'll be part of that vignette. All right, so therefore, it can only help you if you know it, but it's not going to make or break the question. Okay?